Hello, hello. Is this audible? Is this audible? Oh my. Wait, is this fine now? Hello, 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 hello. Hmm. I There will be a 1 minute. There's a slight delay, so I'll try to manage. So guys, you can hear me, right? See, bro. Anyway, guys, can you guys hear me, right? I wanna know. Fine. Is, is there any issues with the stream? Like, um, better now. Hi guys, is the stream better now? Is it better now? Audible? Is it? Okay. I guess you're gonna do this without a webcam. Okay. Okay, guys. What do you think? What do you think of robot movement and control is? Hello. What do you think robot movement and control is? No. Let's go. Okay, if you look at a robot, how do you think it moves? How do you know how to turn it properly? There is motors, but then how do you know which speed to go at and everything? And then how does it like accurately judge where it needs to go? Like if you say tell an robotic arm go to, I don't know, some 2 comma 3 in this place, 2 comma 3 comma 5. How do you think it goes to that position accurately? Or like you tell like the vacuum robot, the Roomba, it needs to go straight, right? Needs to, not only straight, it needs to like go through the whole house and then map, find out every place. And how does it know where to go? How does it calculate where to go? Hello. Yeah. Robot movement and control. Basically, this is all about finding how to move a robot, figuring out how where it is in the map, find and then trying to go to the accurate location. So yeah, let's start. Okay. First of all, we need to know what motion and pose is. Okay, motion. I guess you guys know what motion is. Motion is just the movement of the robot. How are you moving the robot? How fast it's moving? How fast it's turning? That is what motion and pose is. And pose is just a combination of position plus orientation. It We need to know where on the map or where on the floor or wherever the robot is. We need to know where it is plus which direction it's looking and like how it's oriented because this will all change. Motors and servos, yes, but then how do you control speed and stuff? Were you guys taught PID in the previous sessions? Not much. Okay, can someone like tell me what in PID were taught? Just it's a way to control, right? Was in the previous sessions, did anybody teach you PID control? Okay. Okay, you guys don't know about control. Okay, I should have looked into that. Okay, anyways. Basically, yeah. We need to know where you're looking at. PID is just a way to control where you need to go. Yeah, it's a feedback loop, correct. Yeah, okay, yeah, you guys did turtle, right? So you guys know the position and then how to turn to the correctly to whatever angle you want. Yeah, that is PID, and that's it. And that is position, and motion is this one. And when you start motion, you need to have like a frame of reference, right? You need to know something which is all some position which is already known. Yeah, usually we have three different types of references. Basically, the first one is the world reference. Basically, that's like the origin of your ground. Yeah, I'm gonna come to that. The origin of your ground. Like this is where all the coordinates will start from. This is your origin. This frame will not move. This reference will not move. And yeah, there's another one is robot sensor and the robot frame and the sensor frame. I'll tell you what's the difference. Even though both move in the same place, the robot frame is like the origin of the robot. It's where the center of mass of the robot or all the velocities act on. So if you say go at like I don't know 2 meters per second, that's this point we consider this point to be moving at 2 meters per second, not any other point. And sensor frame we don't tell anything to this. Sensor frame will give like the position. Let's say the sensor is some lidar. Okay, you guys know what lidar is, right? Okay. Now LiDAR, it'll give you the distance from, yeah, now you know distance, right? Now the sensor will give you the distance from the object towards itself, but we need to find the distance from it to the robot, not to the sensor. The sensor can be anywhere on the robot, but it's not on the center of the robot, right? So this is why we have a third frame of reference. We just get the distance from this and then convert that to our robot frame reference. It's just like shifting origin, so that we know where it is, or like shift it to the world reference so we know the exact position of the obstacle, or like whatever distance it's trying to find. Any doubts? I'll wait. Also, guys, there's a 30-second delay between me speaking and it coming on the screen, so there will be a. So please, like, adjust, be considerate of that. If there's silence for a long time, it's probably because I was waiting for you guys on the chat. Okay, is it buffering still? Is it working now? Please say something in chat if you can hear this. Hello.